All right. So my name is Alex, and I know many of you. And today I will be talking about how MySQL can attack you. So again, my name is Alex. I've been working started at MySQL EB, 2006. Worked for Sun Microsystems, Oracle. I joined Amazon Web Services, RDS, Relational Database Service, about 3.5 years ago. And I created a new team, security team. We call it Red Team. So we are doing security research. Our goal is to try to find any security issues, MySQL, MariaDB, any databases actually. We are trying to attack our own services to be able to find anything there. So this is what I'm going to demo today. Right? So imagine a MySQL server. And imagine someone controls that MySQL server. For example, you're running a website, you're running a WordPress, and someone actually hacked your WordPress database. Now you notice that it's hacked, there's nothing there, nothing interesting there, you just restore the backup, right? And then to restore the backup, you connect to the database from your workstation, right? And then you get hacked. Right? So a bad actor will take complete control of the database administrator workstation. So the question is, how is this even possible? So I will be demonstrating this attack, and you may be scared, and whatever you see, you will not be able to unsee. So if you don't leave now. All right. So this is what we will be our agenda. So the remote code execution in MySQL MariaDB client library, directory traversal. I'm giving you all the information ahead of time. So it was silently fixed in 2019, and in 2023 we were able to find a way to bypass this fix by using multi-byte check. All right, so let's take a look. So I started with the question, how this is even possible? So to understand how this is even possible, we need to understand MySQL authentication protocol. And I created this oversimplified picture explaining what happens during the MySQL hour. So MySQL client connects to the server and say, hello, MySQL server. I need to authenticate. I have my username and password. And by the way, I will be using the MySQL native password plugin, which was created in, I don't remember, 19. Anyway, right? And then the server says, very good. I loaded the MySQL native password plugin, and I have checked your username and password using that plugin. Access granted. Okay? So now, here's another story. MySQL client say, hello, MySQL server. I have username and password, and by the way, I use whatever plugin. And MySQL server said, I don't know what this whatever plugin is. Let's try another plugin. And the client will say, okay, I will load that another plugin, right? If I have it. So then, here, what happens is MySQL server will tell client what plugin to load. It's actually not very usual thing to do, right? And MySQL client say, I will load that plugin. What that load means? Load means plugin is a shared library, right? It's a shared library on Linux, it's DLL on Windows. So load actually means that it will do deal open call on Linux and load library colon window, a system call, right? And this is me looking at this. So let's take a look at the client library code. So we can see deal open here, right? And then, but before deal open, it will prepare the string, the deal path string. And then there is a plugin name here. Plugin name comes from the server. Plugin dir is a dedicated directory for the plugins. And then the client will do a load shared by. Right? So this code is taken from MySQL 8018 SQL Common Client plugin. This code is shared between server and client, but actually this is used in any client libraries. MySQL Command Line client, or you use something that's based on the MySQL client plugin code like Workbench or CLI, something like that. This will be used. So what kind of protections do we have? Well, first of all, we have a plugin dir. Plugin dir is predefined and defined on the client side. So server will not be able to tell you what plugin dir to use. But what if we will use this? This is an old trick called directory traversal. We specify dot dot slash dot dot slash. Then basically, if you have a deal open on top of that, then you can load any shared library on disk, right? Because you escaped from that plugin dir, right? And this is called arbitrary code execution via directory traversal. So this is the original security issue. And it actually was found in 2019 in both MySQL and MariaDB. It was submitted to HackerOne report. And then there's a whole description here. You can follow that link, and you can see what this reporter found and what he was talking about. Basically, the idea is that with the directory traversal, you can load any file, any shared library that's already on the box. And then it was fixed on June 12, 2019. I was able to came up with this timeline. I was reported via HackerOne against MariaDB. And then I was fixed and released in MariaDB in August 2nd, August 2nd, right? And then MariaDB has a fix, and it's sanitizing input, right? So check against this to prevent the directory traversal. And then on November 21st, the fix was pushed to MySQL community server. It's not a public bug. This has this bug description. GitHub has a commit, and it assigned the CVE. CVE have some little bit cryptic description. Actually, even at this point, I don't know which CVE it is, but the bug tells the story. The commit, right? The git commit tells the full story. The same story that has been told on HackerOne, right? You can do a directory traversal by changing the plugin name, right? So that was fixed. And then this code was added to the MySQL server. Again, this is client utilities, it's shared code. And I said, no paths allowed for the shared library. A little bit different implementation from MariaDB. So the summary, all the MySQL MariaDB versions can actually push the full path. And this is fixed in all these versions. If you guys are using this version 8019, anyone using 8019 client license, you need to upgrade immediately. All right, so how does it work? So now I will tell you step by step what you can do to actually achieve this. So again, this is our picture, right? So we control the server. We don't control the client. We want to control the client. So the server can be any version. It doesn't really matter. We create our own custom code resembling MySQL, implementing MySQL protocol. And then this is the requirement. It needs to be vulnerable old version of the client library from before 2019. It can be anything. It can be MySQL command line. It can be GUI tools. It can be Workbench, right? So we need to control MySQL MariaDB server. That's a prerequisite. We need to have this vulnerable version. We need to ability to push exploit code as a shared library. So this shared library should be on the workstation here. Right? This sounds complicated. Now let's do step by step. So what we will be doing here is, how do we push the plugin name via directory traversal? That's the first question. So what we'll do is we'll write a rogue server in Python. We will write a very small server which will implement MySQL client protocol. This is our plan of attack, right? So we write a rogue server, we'll load the arbitrary file as shared library, and then we push the exploit code to the database administration. How do we do the server? Right? So there is a good news. Python have this MySQL mimic. I don't know, anyone heard about MySQL mimic? All right, so this is very easy now to implement MySQL protocol. It implements everything. It implements protocol, it can do SSL, it can do lots of things. So I started playing with MySQL mimic and I created a very simple code. It's basically import the server, right? And then it will push the plugin name. You can actually create a customized out plugin and customized identity provider, where you can specify the name of the plugin that the client will try to use. So then it's easy to use. You can specify in the command line, you can specify the path to your shared library, and that's it. You can listen to any port. So now, this is our first proof of concept. What we want to do is we want to push, we just want to understand, will it work or not, right? So we put our directory traversal, load, start the workbench, and connect to this data source, right? This 8018 is the MySQL ODBC Unicode driver. It's not the service client. It's based off the same code that has this directory traversal. So now when we try to establish the connection to our server, to our Python script, we get this, no such file. So it indeed try to load deal open of this file. So this is working. Yeah. Our injection worked. So step 1 done. Step 2, loading arbitrary code of the shared library. So how do we actually load the exploit code? I would start thinking, well, I need to create a plugin. I took the code from MySQL server, implementing the plugin, and then I realized I don't need this. When you load the shared library, there's a constructor, there's an init, and destructor. So I just put this thing in it. That's it. It's just how many lines? 2 lines, right? 5 lines, 6 lines of code. And then you compile it as a shared library. And then what I do here is I create a file, and then I open a calculator on my Mac. So this is step 2. That's super easy. But then I was thinking, will be nice if I can actually load arbitrary file name But this is not what it is in the code, right? So it appends SO extension. SO extension is a OS specific. On Linux, it's a .so. On Windows, it's DLL. So let's look at the code. This code is from 1984. Richard O'Keefe, actually very famous guy. So this code is still in MySQL 8.0 source tree. And it's actually length overflow. So what you can do here is, if you calculate your name correctly, you can override the SO file. And you can then push arbitrary file. So let's take a look. So we have unfixed old version of client. I connect using my Python server, right? And this is our client connection. So I created this very bad example of Python code. I'm not a Python developer, don't judge me on that. This is also pre-ChatGPT, so I was unable to use ChatGPT. So basically what it does, it generates an injection stream. So it just calculates that precisely to go over 512 bytes minus the SO file, right? So 512 minus plugin dir length minus length of a file name minus length of traverse, the slash, and then -1. So then we can actually now load any file. We can create TMP, PNG, and then we'll load that. All right, so this is our test, just to make sure that this concept worked. I have created this whole string, and then I use MySQL command line client to connect, and actually it worked. It gave me an error, but it doesn't matter. It actually worked. I verified with the S-trace, right? So that it was actually issued in the open-add command. But let's fix the last problem that we have. How do we actually push the arbitrary code to your workstation? Right? That's the hardest part of that. What we can do is we can use some sort of disguise, right? We can load any file disguised as a resume. So if I send you my resume on LinkedIn, what would you do? Right? You will not execute it. You will just save it on an arbitrary location somewhere. Maybe if you're using Mac, you will save it in documents, your name, like home, or users, your name, documents, right? And then my file name. I know my file name. So the difference, the huge difference between the general attack is that you don't need to open it. You don't need to execute it. You just need to save it. And that's it. We need to have something on disk. So I will show you, 10 minutes left, I'll show you a couple demos. Not a live demo, but the recorded demo. So this is the first demo. So I have created the shared C file. And I saved it as a resume. My colleague Martin sent me the resume. I saved it in here, users, A. Rubin, documents. And then I created this, the hacked MySQL server, right? Wait for a second. Right? So I created this hacked MySQL server, and then I calculated the length. And now, as a DBA, I connect to my hacked database. Right? This is an old one, Workbench. 8013. So now I'm trying to connect and make sure that the plugins are here, right? Some of them doesn't have the plugin. That's another complication we'll talk about. And I establish connection, and then I have calculate. So it gave me an error, but the calculator is done. So that means that I have full control over this workstation just by having you save my resume on this. All right. So Windows. Windows works pretty similar. Pretty much the same thing. Let's actually skip that Windows demo. So now we found a new thing, a new discovery. In February 2023, we discovered a new security issue. So the new discovery timeline, right? So in February, we discovered a bypass to 2019 fix with some condition and reported it. And in April 18th, the issue was fixed in MySQL E03357. Right? It received the CVE, and you can also see the commit. So this is basically the commit. And the idea is simple, that you can use the character set. If you control the character set that client have, it's more complicated and more conditional. But if someone is using the different character set, then there's check in this function. You remember that function? Doing that in 1984, right? In 1984, there were no UTF-8. Maybe it was, I don't remember, but definitely was not UTF-816 or UTF-832. So then, basically, I will have to go through and skip some of the slides, but I wanted to show you how it works. So here we use the newer workbench, but still the old at this point, 8030. Right? And then we assume that the DBA is using a very unusual setup, UTF-16. Right? UTF-16. So I set my old chart set name as UTF-16, and I do the test connection, calculate it. Right? So somehow this code that was protecting us didn't work. Why it didn't work? Because in UTF-16 it's 2 bytes. And you're skipping over 2 bytes. And then your dot is skipped over. Dot slash is skipped over because dot is allowed. Only dot slash is not allowed. So now we have another. So let's look at this demo, and then we'll do the continuous. All right, so we have, this is Windows. We have created this Ember2 DLL. I hope it is visible. Sorry for black. So we have this version 8032, right? And we do the, yeah, thank you. Oh.
Sorry.
Yeah.
Okay.
Oh. Okay.
Go back for a second, right? 8032. We try to connect to my rogue server. So there's no path allowed, right? Remember this issue fixed in 2019. Now is the slide -- default character set UTF-816. And then you have this. Boom. Right? Because it skipped over. It didn't check. All right, so this is fixed in Protector's MySQL version. And let's verify that it's being fixed. So what version is it? It is 33. So supposedly it is fixing 0.33. All right, so let's try it again. Connect to the server. Cannot be loaded. Now let's try the UTF-816. So what do you think will happen? It's a different error. There's no calculator at least, but it's different error, right? So it actually decided that client libraries in this scenario should never support the UTF-16. So this is the fix. All right. So we did it. We attacked the database administrator machine. We found the security issue. We submitted it to Oracle, and Oracle fixed it. So, quick recap. Version affected. 2019 issue. All the versions, probably all the versions of MySQL MariaDB Percona server before that date, before that 2019 is affected. Again, not the server specifically, the client utilities. Applications too, right? If the application is built on top of the ODBC or MySQL CLib, they're also affected, right? So this example is for attacking the database workstation, but it can be also other servers, right? Like application servers. 2023 issue, UTF-16, check the bypass, fixed is released April 2023. Old versions, again, not affected. What is not affected? GDBC not affected, native implementations not affected. Like if you're using Go, you're using Python native implementation, it's not affected. It's different code. But lots of classes of GUI tools are affected. Workbench, Navicat, SQL Pro. If you're using, especially if you're using very old version or relatively old version of like GUI tool, then it may be affected as well. All right. Finally, summary and conclusions. Rogue MySQL can attack client. Original issue fixed in 2019, the new issue fixed in April 2023. And always upgrade. And if you have a C function written in 1984, then probably you need to think about check the set. All right, questions?